Well, the question is, a particle is moving in a circular path of radius a under the action of attractive potential U is equal minus k upon 2r square. Its total energy is, well, first of all, the particle is rotating in a circular orbit, okay, of radius a. So total energy is nothing but potential energy plus kinetic energy. Well, so potential already given, so we need to calculate the kinetic energy, and we will add them finally. So let us first calculate the, how can we calculate the that one, kinetic energy. Here you see potential energy is given as U is equal minus k upon 2r square. Okay, it is not potential energy, it is potential, but we know that force equal to minus du dr. Okay, it means negative gradient of potential is called the conservative force. So F equal to minus du dr. So if we differentiate it, that is what? That is nothing but r to the power minus 2, no? So after differentiating it, we are going to get minus 2, r to the power minus 3. So it means 2 will get cancelled. So kr cube. Minus minus, it will become plus only. So it is the force. And which is nothing but the, as it is attractive potential, it means this is nothing but the that one force towards the center, which will provide the necessary centripetal force, mv square by r. F is equal to mv square by r, which is equal to k upon r cube. In fact, that r is nothing but a only. Okay, r is from the center only, so you can directly write a cube. So it becomes a square. No? So if I multiply both side by half, so half mv square is equal k upon 2a square, and that is nothing but kinetic energy only. So kinetic energy equal to k upon 2a square. Well, potential energy was minus k upon 2a square. So the total energy is what? Minus k upon 2a square plus k upon 2r square, 2a square. So ultimately total energy is what? 0. So out of the 4 options, C is the correct option.